So welcome to Aviation Safety Management Systems. To get started in this course, we need to set some foundational concepts up. These foundational concepts, they're clearly articulated in your reading material and in your presentations, but I wanted to take a moment in this video to draw them out and explain some of them to you here in this video. So for starters, let's talk about safety. Safe, for that matter. What is safe? The dictionary defines safe like this: the condition of being free from undergoing or causing hurt, injury, or loss. But really, is that even true? Here we are, we're in upper level education. The dictionary definitions can be a bit rudimentary for us, and so we need to do a little deeper digging. After all, are we ever really free from the potential of hurt, injury, or loss? Well, no. When you drive, you can crash. When you walk, you could trip. When you exercise, you could pull a muscle. If you never got out of bed, you risk all kinds of other problems, right? Lethargy, bed sores, diabetes, weight gain. So let's move this concept of safe into our world of transportation and see what comes. Is transportation safe? If you are one of the millions of people who reach their destination without incident, well, you might say yes. There's a very slight probability in commercial aviation that you will become an accident statistic. Much greater probability in general aviation that you become an accident statistic, but we'll cross that bridge later. In commercial aviation, however, you have a 1 in 11 million chance that this flight will be your last. If I were a betting man, I would probably take those odds. But what if you were that one? That one who didn't make it? Is that acceptable safety? I don't know. Rather than free from harm, though, in aviation, we classify safety in terms of risk. Aviation is a dangerous business with a very good safety record. In commercial aviation, that is. We identify the level of risk and then seek ways to mitigate the risk to an acceptable level. That said, here's a definition of safety from the International Civil Aviation Organization. And we'll use this definition of safety for our class. Pay attention to the underlined words. We're going to go deeper to them in the next slide. So read that definition of safety. In the safety definition, we identified risk. That is the composite probability and severity of a mishap. The probability that a mishap will occur and the consequences, that's the probability that a mishap will occur and the consequences if it does. Risk reduced to is also in the definition. That is, controls are put into place to mitigate the identified risk. You ride your bicycle on a busy street, you have a high probability of being hit by a car and suffering severe injuries. You wear a reflective vest to reduce the likelihood of getting hit, that makes you more visible, and you wear a helmet to reduce the severity of injury if you do get hit. Okay? The next concept is maintained at. From our definition. Maintained at. We don't just put controls into place and then forget about it. We continually evaluate and re-evaluate the risk. Perhaps we decide to take a different route that's less busy on our bicycle. We go a different time of day when there's less traffic. Okay, reduced to or maintained at an acceptable level. Even with a reflective vest and a helmet, we still assume risk while riding our bicycles on a busy street. There are drivers who are distracted on their cell phones, which don't ever do that as a driver, please. We acknowledge that there will always be risk, but we measure it and determine whether or not it is reasonable and whether it is tolerable. That leads me to one of my favorite quotes in aviation. In flying, I have learned that carelessness and overconfidence are usually far more dangerous than deliberately accepted risks. So identify hazards and mitigate the risks of those hazards. Let's now delve deeper into those two terms. Risk equals likelihood times severity. You will see that later in this course that we can later in the course that we can describe and assign actual numerical values to severity and likelihood. Those ratings then, taken in concert with each other, give us risk that can be plotted on a risk matrix. So the risk matrix gives us a visual depiction of the severity, that's here, and the likelihood. The resultant risk that you get as you combine the severity with the likelihood, the resultant risk that you get in the middle is acceptable, or it's acceptable with mitigation, or it's unacceptable. We also talked about hazards. In safety, we intentionally seek out and identify hazards because it is the hazards, if left unabated, that can lead to unsafe conditions and mishaps. This is crucial and is on your quiz and test. A hazard is a potential threat. It's a potential threat. It's not an active occurrence. It is a tree. A hazard is a tree or a cliff, as in the Calvin and Hobbes cartoons in the PowerPoint. In aviation, a hazard is a thunderstorm, mountainous terrain, etc. It may not impact your operation. Your risk analysis will determine whether or not the hazards, impact your operation. However, hazards are ever present, potential threats, so we seek them out. So we've reasoned now that safety is a continual process of risk mitigation. Risk is an objective measure of the severity and probability of a mishap resulting from a hazard. A hazard is a potential thing, something out there that could cause a mishap. So, this was to present you with a foundational understanding of these key concepts. I hope you enjoy the course, and I hope that you find that you can practically apply this material in your daily lives and in your professions.